This video is about derivatives of trig functions, focusing on sine and cosine. So the derivative of the function y equals sine x is y prime equals cos x, and the derivative of the function y equals cos x is y equals minus sine x. So the first few examples that we're going to look at are just differentiating functions that involve sine. So the first one is y equals x cubed sine x. So you've got two functions that are multiplied together. So that means that we're going to have to use the product rule. So to do y prime, we are going to have g times f prime plus f times, here's our trig function, g prime. Then we can simplify this a little bit further by factoring out the x squared, and we can write it as 3 sine x plus x cos x. Now, the next one that we're going to look at is y equals e to the x over sine x. So here we actually have the quotient rule. And just for fun, we'll do the long version of the quotient rule. And I'm going to write it out here. So we've got f at x is just e at x. F prime at x is also e at x. Then we've got g at x is sine x. And g prime is going to be cos x. So now we're going to look at using our product rule. So our product rule is we've got g times f prime minus f times g prime all over g squared, which is going to be here. Okay, and we'll just double check. So bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So that's all good. Let's see, can we simplify a little bit further? Not really. We can factor out the e to the x on top. And then we'll leave our bottom as sine x all squared. Our next example is with a ln function. So y equals the ln of sine x. So here we've got a function within a function, so we're going to have to use the chain rule. Exciting. And so what we're going to do to take the derivative is we're going to go 1 over the argument of the ln, because that's the derivative of the ln. Now we have to multiply by the derivative of the inside function, which is the derivative of sine x, which is cos x. And here we can actually simplify this to y equals cotan x, but that's not necessary to simplify that. The important part is that you're using the chain rule to accurately differentiate this function. Okay. These next two have cosine in them. Okay. And so here we've got product of two functions. Let's put a y equals on there. So here we've got our f at x is the first one. G at x is the second one. So here we're going to use the product rule again. So we've got f and f prime. And then we've got g and g prime here. And then we're going to take the derivative here using the product rule. So we've got y prime equals, let's see, where are we? G times f prime plus f times g prime. And then we can simplify this one a little bit further again by factoring out minus e to the minus x, which is going to leave us with cos x plus sine x. And we could really, if we wanted to write this even further, y prime would be minus 1 cos x plus sine x all over e to the x if we wanted to write it with a positive exponent. The last one that we're going to look at here is cos to the 4x. Okay, here we're going to use the chain rule again. And we've got, let's put a y here. So we've got y prime. We're going to bring the 4 down. So we've got 4. Let's rewrite this so it's a little bit easier to see. So we've got y equals cos x to the exponent 4. Sometimes that's a little bit easier to see. So now we've got 4 cos x to the 3. And then we're going to multiply by the derivative of whatever's inside the brackets. So minus sine x. And then we can simplify this a little bit further to minus 4 sine x cos cubed x. And that's the derivative. So let's do a couple more examples. Here we're going to use trig functions again, sine and cos. And this time the arguments of the trig function are where we're going to apply the chain rule. So we've got a little bit more complicated derivatives. We'll do a few more examples. Here the first one is sine x squared. So to take the derivative, the first thing that we're going to do is take the derivative of the outside function, and we're going to leave the inside function the same. Then we're going to multiply by the derivative of the inside function, and then simplify our final answer. Let's try another one. Here we've got sine e to the x, so our outside function is the sine, our inside function is the e to the x. In order to take our derivative, the first thing we're going to do is take the derivative of our outside function, leave the inside function the same, and then we're going to multiply by the derivative of the inside function, because that's what you have to do according to the chain rule. We can simplify it a little bit further to get our final answer. The next one we're going to look at is even more complicated here. So we've got sine of 1 over ln x. So we've got our outside function, which is the sine. So that's the first thing that we're going to take the derivative of. So we've got cos, and we're going to leave our inside function the same. And here we've got a double chain rule. So now I'm going to multiply by the derivative of the inside function, which is minus ln x. But now I've got another to the minus 2. And now I've got another inside function, that ln x. So now again, I have to multiply by the derivative of the inside function, the derivative of ln x, which is 1 over x. Now I can simplify this a little bit further. Let's see what stays on top. Minus cos ln x to the minus 1 all over ln x to the 2 times x. Pretty complicated final derivative, but that accounts for all of the pieces of the chain rule. Okay, we're going to go through a couple more examples. Here we've got 2 trig functions. So again, we're going to start by taking the derivative of the outside function. Now we've got cos, so we've got minus sine. Keep the inside function the same. And then we're going to multiply by the derivative of the inside function, so the derivative of sine x, which is just cos x. And now we can write it as minus cos x times the sine of sine x. Okay. Next one here, we've got y. I'm just going to write it like this. So y equals cos x to the minus 2. So I'm going to take the derivative of the outside function first, which is the cos, leave the inside function the same, and now I'm going to multiply by the derivative of the inside function. So minus 2x to the minus 3, because my inside function is this x to the minus 2. When I write my final answer, I'm going to simplify that a little bit. So I've got two negatives. Those are going to make a positive. I've got sine 1 over x squared all over x cubed as my final answer. Last example that we're going to do here is cos of e to the x squared. This is our inside function. And here again, we're going to have the chain rule twice. Okay, so we'll start on the outside and work our way in. So we've got y prime. We're going to take the derivative of the outside function, the cos, and leave our inside function the same. Now, we're going to start by multiplying by the derivative of the inside function. So we'll start with that e to the x part, which is e to the x squared. But our e also has a function in the exponent. So now we have to multiply by the derivative of that function in the exponent. So 2x, and then we can write everything all together as minus 2x e to the x squared sine e to the x squared. So these questions go over, again, derivatives of trig functions, focusing on sine and cosine. So what you should work on is 14a, which gives you some more examples.